Hello guys, welcome to my page. This is Maths with BigBen, and I find this video very interesting and fascinating for we to learn from.
You know very well how to find out square roots of large numbers. Say you can find out the square root of 1,20,409 either by prime factorization method or by long division method. But we know that numbers don't exist like this only. There may be a number, say 12.0409. Then what will you do? Then how do we find out the square root of such a number? Let's see. Well, this can be found out by long division method again. Now the long division method remains the same, only slight changes are there or slight differences are there. We'll see what are they. See, first of all, we write the number like this. What is the first step in long division method? We start placing the bar. How do we place the bar? We place the bar from the ones digit, that is from that side. But when it is a decimal number, then this thing changes. What we do is, we place the bar separately from the decimal point. From the decimal point towards the ones digit, and after the decimal point from this side only, that is from left to right. So let's start placing the bar. From the decimal point to the left, we will place a bar over a pair of digits like this. Suppose one digit were there, say 5 here. Then you could place a bar over that also. So remember, when there is a decimal point, start placing the bar from the ones digit before the decimal point. Now what about the digits after the decimal point? Well, start placing the bar from the left hand side only. That is from these numbers. So you go this way. So when there is a point, say a decimal point, you start placing a bar first this way, and then for the digits on this side, you start placing the bar from this way. So let's place a bar here over pairs of digits. So we've successfully placed the bars like this. Now what do you do? First step was placing the bar. Next, we take this first pair of digits. Now think about a number which when squared gives a number less than or equal to 12. Think about such a number. Well, think about the squares of natural numbers. What is 3 square? 9. And what is 4 square? 16. So which number can be taken here? 9 can be taken because 16 will go beyond 12. So 3 into 3 gives us 9. Why are we doing this? Because this digit here and this digit here, this quotient needs to be the same. So subtract this. 12 minus 9 gives us 3. We are done with this. Next, what we do? Next, we copy the next pair of digits. But the thing is, here we have a decimal point in between. So whenever we have a decimal point here and you finish with the digits before the decimal point, just put this decimal point in the quotient as well. And your decimal problem is over. So you don't need to care about the decimal anymore once you have put it here. So what did we do? First, finish off with this digit. Say 3 3s are 9 and you got the remainder. And so the work of this 12 is over. Now you saw before bringing down the next pair of digits, one point is there. So put that point in the quotient as well. And your game of decimal point is over here. So copy down 04 now. Next, what do? We double this quotient and write it as a new divisor. So we'll do it again. So 3 doubled, we get 6. And we put a blank towards its right. So we do it like this, and we have to find another number here. Well, what will be that number? We remember that the number here has to be the same number which when multiplied with this whole number gets a value less than or equal to this new dividend. So the digit we are going to put here shall be the same digit we have to write as the next quotient. Right? So just recall long division method. How do we do that? We'll do the same thing over here. So find out that digit here. Well, 63 into 3. What will we get? 189. Well, that is less than 304, but let's verify again. 64 into 4. You can see we are using the same digits here. So 64 into 4, what do we get? 256. Well, this is even less than 304, but let's try another number. 65 into 5. Now this is going beyond 304, so the option that we'll take is this one. So put 4 here and put 4 here also. Now find out the remainder. What do you get? Now after we find out the remainder, what do? We copy the next pair of digits, that is 0, 9. That is exactly how we do long division method. The decimal problem was over here. So copy 0, 9. Here. Now what do? We have to double this quotient and write it as the new divisor. So doubling this, what we'll get? 34 into 2. And put it with a blank right next to it. So now we have to find a number which when multiplied, or you can say which when put here and then multiplied with the whole number, we get exactly the same or a value less than this new dividend. So think about such a number. Well, let's check with some numbers. Say 686 into 6. What do you get? Well, this is less than this, but then we have to check with another number. Check with this. See, we have arrived to the exact number. So let's write this. 7 here and 7 here. So 4, 8, 0, 9. Well, the remainder is 0 because we have got the exact digit. So we can say that root over 12.0409 is 3.47. This is the square root of this decimal number. Now, every time a decimal number may or may not be a square number. So here there is a number, say 5.462. This is not a square number. Or say, I am not sure whether this is a square number or not. So now let us find out the square root of this number. Well, if you notice closely, you can see that both ways the pairs of digits cannot be grouped. First of all, what we do? We start from this way. That is, before the decimal digit, we go this way. So I cannot pair it. So let me put a single bar on a single digit. Now we go towards the right after the decimal point. So first pair can be formed, but again 2 is left behind. But as I have put a bar over here, I cannot put a bar on a single digit after the decimal point. Then what can I do? Well, you know that if there is a number, say 546. This is 546. I can put a 0 here. If I put a 0 here, is the value of 546 changing? Well, obviously, from 546, it has become 5460. So, putting a 0 here changes this value. So, this is not possible. But, what if I say 5.46? This number and 5.460. Now, is there any difference between these two? Tell me. Well, if you know the concept of decimals very well, you can tell that 5.46 and 5.460 are exactly the same. You can add any amount of zeros after this, but even then the value of 5.46 and the 5.460000 will not differ. It will remain the same. So here what we can do, we can put a 0, because adding a 0 to 5.462 will not change its value. So if I'm adding a 0, my work is being done. I am getting a digit for my bar, because these digits need to be in pairs. So I can add a 0 only if it is a decimal number. Remember, do not do it if this is not a decimal number. If this is a decimal number and you are getting a short for a digit to become a pair, so you can add a 0. But in a normal number, you cannot do that. So here we have got a pair exactly. Now how we will proceed? Well, just now I have taught you how to find out the square root of a decimal number. The same procedure will be repeated here. So find it out yourself. First of all, we'll think of a number that is when squared will give us less than or equal to this number. Well, even on seeing this, I can remember that 2 squared gives us 4, and that is the only digit which will get us equal to or less than this, or otherwise 1 could be the digit. So let us take 2 into 2, 4. Now subtracting it, we get 1. Now what is the next step? Copy this down. Well, again the same thing. Point is here. And before copying this down, you have to put this point on the quotient, so that the decimal thing comes on the quotient as well. So this decimal point has been put on the quotient just after we finish with the digits before the decimal point. So now copy this 46 here, that is the next pair of digits, and double this quotient to get the new divisor. So doubling this, what we get? 4. Put it with a blank. Now think about the number which when put here and here as well, that is multiplied with this whole number, gives us a value equal to or less than this. Think about, say 43 into 3. What do you get? 129. Less than 146. But to be sure, let's confirm. See, we had got the right one only first. Again, we are done with this. Now what do? We copy the next set of numbers. So we have copied the next pair of numbers here. What do we do next? We have to double this quotient and put it here. Well, do not double 2.3 and write down 4.6 here. That is not the thing we are doing here. We are just doubling the quotient without the decimal point. And put it here or a blank. Now think of a number. The same procedure here. Well, this is 2 less than 1720. Let's think about another number. Well, this is also less. Let's confirm. Well, this is going beyond 1720. So we'll take this one. 1389. Find out the remainder. Now just now I told you that if you add, say, a 0 or 2 zeros, 3 zeros or any number of zeros after a decimal point in any number, in any decimal number, the value of the number does not change. So again, if I want to say put 0 here, I want to add some digits so that I can continue the sum. So I need to put some digits here. So 0 is the digit that I can put here, because any decimal number will not change its value if I am putting any number of zeros after the decimal point, that is in the last of the digit. So here I can put a 0. But will that help? See, we need digits in pairs. You can see that. We need digits in pairs. So we have to put 2 zeros here. Again, this will not affect my decimal number. So adding 2 digits gets me a bar as well. So what do I need to do? I need to copy this bar here. That is the pair of digits here. See, I am getting a new dividend for my sum. So I can now continue this sum. Now what do I need to do? I got the new dividend. I need the new divisor. We have to double this to get the new divisor. So doubling this, what do we get? 466. Enter it with a blank on its right. Like this. Now again, the same thing will be repeated. Think about the digit here that when multiplied with this, get us a value equal to or less than this new dividend. What will be the digit? Let's check. Well, this is close, but then we have to check. Well, this is again quite close. Now you can see that this one goes beyond this, so we cannot use this. We will use this one. So let's write it. Well, we'll get a remainder. We got a remainder, but then we do not need to do it further because we were asked to find out the square root up to 2 decimal places. Now suppose if you are asked to find out up to more decimal places, what will you do? Again add pair of zeros, put bars in front of them and continue with the sum. Here we have got 2.337. Now we can see that the last digit is more than 5. So we'll round it off. We get 2.34. So this is the square root of this sum. That is 5.462 when square rooted gives us 2.34.